In this lesson, we're going to look at the video analysis of a falling object. So as we did in the last lesson, first thing we'll do is we will insert the video that we want to analyze, and we'll find that and choose it. And you can see that again in my frame I have a meter scale there. We will enable our video analysis and set our scale as we did before there, and then scroll over to where we want to begin our analysis, which would be right here. Right as we've just let go of it there, and we will set our origin at that point. I'm going to focus on the bottom side of the beanbag with each of my data points so that I can be as consistent as possible with marking its location. And for each point, as we're marking it there, you can see that in the background again it is plotting the distances along the x-axis as well as the distances along the y-axis. And so now we'll click on that, and since we're really only looking at motion in the y-axis, the vertical axis, we'll choose the y, and you can see that we definitely do not have a straight line as we had before, but we have a curve. And remember, on a distance time graph, the slope of our graph tells us what the velocity is. And since we have a curve here, then the slope is constantly changing, so our velocity is constantly changing, so we have an acceleration here. So I'll go to curve fit, and I'll choose quadratic and try it, and that fits my data very well, as we would expect for a falling object. Now, to look at the velocity and how it's changing, we'll choose y velocity, and you can see that except for probably these last two data points down here, we are getting motion pretty much in a straight line. Let's just select all of those data points and zoom in on them, and then do our line of best fit, and you can see that that's pretty good. Now again, on a speed time graph, the slope of the graph is going to give us the acceleration, and you can see that our acceleration here is negative 12.5. That's not what we would expect for a falling object. So you might want to look at our procedure here to see why we are not getting a value of negative 9.8 as we would expect. So here you can see that for falling objects we do have a non-constant velocity, we do have a curve and not a straight line, which would show us on distance time that the object is accelerating. And if we look at velocity time, we do get a straight line, which straight line with a non-zero slope, which is showing us again that the object is accelerating.